practicing our boxing.
Yeah, just sit. You know.
So what, have you ever been in a fist
Are
fight?
you gonna rate me good? Because I did good.
Okay. Question.
Yeah, I don't know how you keep it up.
Oh! I thought it was in my book.
I don't know.
Good.
It's just how I
All right.
We did a project.
Okay, all right, for those, raise your hand if you have not received a practice test for calc. It should be the people that were gone. It is the people that were gone yesterday. It comes in 2 pages.
What are
If
you
you want anybody to help, it's me.
The other side page.
No.
Hey, I need a stapler.
Yeah.
Oh, no, that's why I love me.
Yesterday, Grace was like, hey, can I have a sandwich? He said, no,
Yeah,
don't.
harder, harder,
And
harder.
she's like, what?
Do you think we are more prepared for this test?
Okay, anyone else?
So, my plan with my software.
You guys know the drill, how it works now.
When I worked out the investment, at the point of the
I'm going to just
pizza and
Good
stuff.
job.
Are you stable?
And-
So not gonna.
Would you like that?
Right here.
Why?
Don't cry.
I want the two. One right there, one right there. One.
Put it in this.
Look at mine. I think you got
Does this say phonics on this stuff every freaking day? Yes. Monotonous.
That year.
I don't know how to say words.
That's what
I've only been taught
chemistry
stuff. I don't need to know this stuff everywhere.
All right.
Why do I need to know this?
I think you already got one.
Not being food.
All right,
I
hey,
don't know
where are you
if that's
sitting right now?
All fat. What's up, fat man?
And he's turning.
All right.
Anybody else? Yes.
I would like
A
to.
hog.
Oh.
Hey, we have a lot of stuff to cover today. Make sure you have your practice guide out. All right. Let me zoom in one more time. All right, here we go. All right, practice guide. Our test in here is on Thursday. The reason why it's going to be Thursday, I want to give you at least 1 week if you wish to retake. You can see your scores Friday, and you have 1 week. Here's what I asked for. All retakes have to be done by next Thursday, a week from when you took the test.
Are we gonna be here Thursday?
I don't know, all right?
I don't know what time you get out of
So.
class.
Can we do it Friday? I have 3 tests
Nope,
on Thursday.
nope, Thursday. So, if you're not here, you're taking it Friday.
All right.
So let's
Class
not
are on
be here
our own
today.
time.
Be on your own time.
No.
Okay. All right.
If we had a family.
Wait, why is there only one period?
For what?
Because we have to reduce the cheating.
Because we had a Lars
Reduce
class
the
last
cheating,
year.
no
All right,
cheating.
so I didn't know what you know
Cheater's
that
not in
day.
this period of
So
time.
Snapchat. Okay. All right. So practice guide. If you need a stapler, they're up on the desk. They're not stapled, so you can go do that later. Okay. All right. Goal today. Let's flip through this so you can kind of see the actual outline of the test. So you can see kind of the number of questions. Your test looks almost identical to this. The only difference here is that I'll switch a number up like this. This will be a different problem that I just picked out of the book that we had. And number 2, sorry.
Wait, why are
Number
you
2,
doing this?
I mean, practice guys, we get a practice test every day. So, alright. Okay, now, okay, hey, number 1, we're gonna go through all those little bullets. Sometimes ask you to explain, sometimes ask you just to find it. It could be as easy as just a simple sentence or a simple statement. 2, there's a series of A through F short answers for this graph. It should be a quick interpretation of the graph. Number 3, you have to find the limit using the actual properties of limits. So those are where you can break them up using division rules or multiplication or addition rules, that type of thing. We'll go through those here in a minute. 4 and 5, you have to simplify using that differential quotient with evaluating the limit at a certain number. So that's finding, the 1 or 2 decimal places if necessary. You shouldn't have
If
decimals.
necessary.
You shouldn't.
Which one?
You should not have decimals.
Number
Just saying.
5?
Yep.
Of which
5
one
and
you
4.
shouldn't have?
You should never have decimals?
You should not. They should be nice ones. Okay. Number 6. It'll be some type of problem that we talked about from that previous assignment, your page 87, where you have to calculate first derivative, an instantaneous velocity. Notice I'm not asking you to set up tables or anything like that. I want you to find the first derivative of this and evaluate it at 2. So it's usually some story problem. Why I put a story problem there, because I know a lot of people just jump to the formula and jump to what they need to do. It's because it's to show you like the purpose of why we're doing it, so you can see the rate of change. So I always throw one of those in there. It'll be something very explicit where they give you a formula you can go off of. Okay, now, if you can't evaluate the formula, like let's say you don't know how to take this thing and plug it into a limit with H's, like this is the definition of limit.
May I have your attention, please? Following two students, please come to the nurse's office to have a shot. Caleb Renner and Braden Renner.
Okay, alright,
Again, Caleb Renner and Braden Renner, please go to the nurse's office.
all day.
We get it, Mr.
Or
Ward.
is there any other
It
Ward just wants us to
Yes,
disregard
it does.
the
Still, Mr. Ward.
the office doesn't know what's important.
All right.
Would you agree or disagree? You have the same amount of talent as Neil Armstrong.
Okay, all right, hey, number 7, after we evaluate this, number 7, you have to figure out the short answer for this, and they're trying to explain, if you're looking at the first derivative, at certain numbers, what would it be if your function was even versus odd? So you really have to understand what even and odd mean, and then how to, basically estimate what slope is at those moments. So that way you can kind of figure out the short answer. It should be something simple. And then 8, hold on. 8.
It was so good.
Whoa, Mr. Ward, how are we supposed to do that problem?
Oh, click it down.
That looks like an absolute, I can assure you
What
that's not what.
Okay, yeah, it's not, I don't know why I just.
does the arrow down do?
What?
You click on the problem?
I was just scrolling over, I don't know, it was just some character. Alright, now, calculating first derivative, this is doing that limit formula earlier that we did for this one, for number 6 and number 5. So you're finding a first derivative of these two, and then the last part is we have to do those graphs of the first derivatives. This is the stuff, right here, is the stuff we were doing on Friday,
Oh, I get it.
and, hold on, and we were attempting to do yesterday with our groups that we had. Okay, we're gonna try, tomorrow is kind of the day. If we have a little bit of time today, I'll jump to these. Because I wanna spend the most time, does this seem like it was the one stuff that was really hanging
Wait,
people
but
up?
they're not gonna give us like options on the test?
No, you have to draw it yourself. That's why we were going yesterday at looking at how to start drawing.
How many
So.
people are here today?
6.
And how many people are here today? When you give me options. You wanna reteach that? No.
I'll do it today after the end, or I'll do it tomorrow, so.
Trust me, it's your fault, Mr.
Alright, now, notice 12 and 13, second derivatives. We do have to calculate a second derivative. Now, if you're paying attention, look up at 10 and, not 10 and 11, but at 8 and 9.
They're the same exact.
You already found the first derivative in 8 and 9.
They're not. Then you plug
You
the
just
first
have to
derivative
go
into the second
again.
derivative.
It's gonna be like that on the
How
test.
do you get 8 and 9?
Ooh.
So that way you don't have to do
You're trying to catch us sleeping.
Well, no, I feel like it's like.
He's gonna catch you.
Snap
it.
We'll see that if we like actually
Give me a little.
plug the second derivative, right?
No, wait, I have a question.
Yeah, the first you can't do the second. Jelly land,
Don't we
and
just
then
put
your
the-
sauce.
Like, what's in the second derivative is like,
Do you think Mr. Ward?
First derivative is W.
is that with an H?
Do you think Mr. Ward did jelly?
Maybe derivative has an H in it.
The derivatives are already
You just
H
catch
and
us
X, and then still get it for H. Okay.
Okay, alright, hey. Real quick, we're gonna go through this. My goal today is to go through number 6, and then tomorrow we'll pick at 7 and kind of go to the end. It just depends on timing. At the end of our 6, I'm gonna go through this pretty quick. I wanna talk about what we were doing yesterday, and hopefully we can like connect what we were finishing with the small group that I had, and try to get everyone else that was gone on the same page of like what we did, so it's kind of a condensed version. I will be posting the video from yesterday. I might even do a second one, just because a lot of people were gone,
Good.
on an iPad, just so you can see. I'll do a little more explaining of it. Because I honestly, I don't know at what point my camera actually died. So I might just re-record just on an iPad, and you can see me drawing stuff.
Should I draw
Okay,
this?
all right. Now, number 1, we have to draw, we have to make a sketch, and we have to describe these objects. That's why I give you a graph here, so we can get kind of a feel for where these things are happening. End behavior is where the tails are going. On this case, since this is a fraction, and these have the same power,
They cancel off.
the tails, basically everything looks like it cancels. That means the tails are flattening near 0. So it is going to flatten, I shouldn't say near 0, it's going to flatten near, since they have the same power and they cancel each other out, since everything would basically divide, you divide the numbers out front, the leading coefficients, so it's gonna flatten near the number 1. So what I mean by that is your tail on the left side Sorry, I have one, sorry.
Oh, okay.
Tail near the left side and the right side will flatten near the number 1, not 0. How we know that? If whatever the numbers are, if they're the same power, you divide these. So if it was like 2 over 4, that would be half. That's where they flatten, right? Because it's 2 divided by 4. If they have different powers, it depends on which one's bigger. So if the top is bigger than the bottom, maybe the bottom's a 1. These things will go to infinity and negative infinity still. Okay? If the bottom power is bigger,
Oh, that one.
If
Oh
the-
my
if
God,
the-
you didn't tell me this.
yeah,
I
if
thought
the
so
bottom
too.
power is bigger, it'll flatten near 0. Yeah. If they're the
But you said it
same,
again in case it was
0
right.
and 0.
They're the
What do you
same
say
when
if
they
the
go.
power's bigger on top?
The power's bigger on the top, they go to infinity and negative infinity. They go like forever
How do we
and down
know
forever.
which one goes
Forever.
to positive and which
That's where you have to look at, what the power
Leading
is.
coefficients.
Yeah, the leading coefficients and look at the numbers positive versus negative.
So let's talk about that one.
All right.
No,
So-
I think you need to go
There's
more
a
in depth.
3
with this
and a
one.
1.
So now, we're flattening near 1. Again, this is the first section. What are you talking
I still don't understand what you're just trying to say.
I understand.
Well,
Kind of. I
how-
just
It's
need
the
to know.
horizontal asymptotes.
How do you know that it doesn't go the other way though?
about?
Like,
Like,
this way?
like flatten
They
this?
can. I mean, it could do this. That's what we're gonna look at with all these graphs. We're gonna look at maybe it's coming up like this way.
I don't know.
Or maybe they're opposites, where it's something like this.
So we shouldn't draw that just at.
No, this is just telling me where the tails are going. So now, to repeat myself, is that if the powers are the same, they'll flatten near whatever the leading coefficients are divided,
Okay.
to 1 in this case. If the power on the top is bigger, they go to infinities and negative infinities, certain way. I don't know which direction it will go. If the power on the bottom is bigger, they go towards 0 every time. They flatten towards 0. So in my case, they're going towards 1s.
The bottom sugar goes towards zero.
Yep. All right, now symmetry. Symmetry is going to be a big deal when we start looking at where the horizontal and vertical asymptotes are going to be. We have a horizontal asymptote at 1. That's the idea. This is the semi-permeable
Membrane.
Okay.
How
So
did you know that was at 1?
because it's that leading number thing. We're
Yeah.
going so that gives me the horizontal. That's why I knew the tails were flattening up against that. Now, to figure out that symmetry, like if it's balanced right and left side, we have to look at the asymptotes. So the horizontal, we already said, right? This horizontal is the way that I look at where the tails go. Vertical is where you have to figure out the factors of the bottom. So,
That's my favorite.
Bless me.
okay, all right. So, I already heard the bottom. When you factor the bottoms, x plus 2, x minus 2.
Yeah.
Because again, you have to be able to factor. That's not a skill that I'm going to teach you. You should have that from World War II breakout days. Okay. So once you have that, that means we're going to have it positive and negative 2. So far, this thing is pretty symmetrical. Just because of balance, that I'm not expecting this to be odd type of symmetry. Just because we're not going to hit 0, 0. It might be even. So maybe the tails go in the same direction
Wait,
kind of
why
thing.
didn't you put the vertical in?
I'll put them in here in a second. But by just looking at where these markers are, everything looks pretty balanced across the picture. Now, the question I have is why didn't I fill in the vertical asymptotes? I'm going to fill those in now.
Oh my goodness, if you plug in 0, it's -1.
All right, so there we go. So there's the vertical asymptotes. All right,
0.
so again, vertical asymptotes are made by the bottom. Symmetry, it looks like it's going to be symmetric. I'm expecting this probably to be even symmetric.
4 divided
Okay.
by -4.
X-intercepts.
That's the top.
The top. We have to factor the top apart. Yes, I will give you a problem that is factorable.
Wait, how did
I'm not going to make it up super difficult. So,
X-intercepts, do what you factor top?
yep, x-intercepts, factor the top. So, we factor the top.
Wait,
I bet it's x plus 4, x plus 1, so
There you go.
-4 and -1.
X plus 4, x plus 1. So, what that means is that at -4 and -1, we're going to hit those numbers on the x-axis. So, -4, that's right, that's 1, 2, 3, 4, and -1, we're hitting here. So, what that means, what that's telling me, is where these tails roughly are going. I'm betting on it's something like this.
How do we know how many different little pieces there are?
What do you mean?
Little lines.
Little
Ross, you can see it, there's 3 sections.
There's three.
Yeah, there's three parts because the vertical asymptotes separate
I
everything.
mean, my last one.
Vertical asymptotes, you cannot cross a vertical
You
asymptote.
cannot.
What
So,
happens if you do?
You can't. It's not allowed. It's undefined. So the idea is that I will have three distinct pictures. Now, why did I suddenly draw that one picture on the bottom? Because I know that on this farmost left side, I'm hitting -4.
Right?
So I know that graph had to be
How do
below,
we know it didn't cross one and plateau on the top of one? So sometimes it does that.
where it kind of goes like up like this.
Yeah.
I mean, we're in the ballpark.
We're in the ballpark.
You have to just give me a rough sketch. Give me a rough sketch.
So not Desmos, but.
No. Okay, all right, now the other graph, I'm expecting something in this one, I don't know, maybe it might look something like this.
You think
Or
so?
it might be like a loop.
Should we plug in one to
We're
figure it
gonna
out?
plug in a couple numbers.
How about just one? Like the number one.
We can do that.
Or a 0, you can see kind of where that thing's going.
Let's plug in.
4 is negative, 0 is -1.
96,000.
So we'll get to that, and then the other side, we'll get to those. Now, y-intercepts, the y-intercepts is kind of a big idea. We have to plug in zeros first. Did everyone understand where I got these two x-intercepts at?
Sure.
Okay, back to the top.
Wait, how did you know that the
In the middle like that?
no,
The left, because I was hitting, the far left side, I knew I was hitting -4. Far left side,
Fraction on a test.
so, yeah.
Okay, thank you.
Okay. Is that, do we get your question, what was your question again?
Sure.
Oh, so it's gonna be a
Okay.
fraction on it.
Sure.
I'm going with
I have
All
a
right.
question.
Oh. Okay, hold on. Let me get through this and I can answer any
Okay.
Because
Okay.
I wanna actually get through the majority of this.
Yep.
Okay,
What
All right.
are we trying to get to?
so, 6.
6.
We have a long ways
We
to go
can do that.
together.
Go, go, go.
All right, so to make the sketch here, we do have to find the y-intercept still. That's where you plug in all the zeros into all these places, and then we can figure out where the y-intercept's gonna be.
-1.
So 0 plus 0 plus 4 over 0 minus 4. So yeah, this thing's gonna hit a -1. So it's down here. So I'm betting on that my drawing here in the middle is probably not accurate.
It might be.
Well.
It might be one of those things, maybe it's coming from the top and looping its way down, like it's going like this way.
Maybe it's a
Why is that
lateral.
on Y again?
Mr. Ward, it could be a
Ooh.
down facing.
It might be something like that, or maybe it's like doing a loop on the bottom.
Maybe you decided something.
Okay. Okay, what was the question? Why did I get -1? Is that the
Why
question?
did you decide it's on Y axis?
That's a y-intercept. When you plug in zeros for all the x's, that's a y-intercept.
Okay.
Yeah, because y-intercepts, by the way, have to look like this. It's 0, number. X-intercepts have to be a number, 0. And so to get to the y-intercept, you have to plug in zeros for all the x's.
It's kind of messed up.
Wait, what?
If you plug in zeros for x's, it's like you know.
Yeah.
Yeah, I
I'm
know,
getting
but
the feeling
why'd you
that's
do
not gonna be
number
so.
0, 0?
Because that's what x-intercepts look like. It's a number, 0. Y-intercepts are a 0,
Oh,
number.
yeah, oh, yeah.
For
Yeah.
Yeah.
So
So
how
that,
do we-
that just kind of explains like why I did it.
I have a
Plugged in 0 for x.
How do you think X is?
We already did that. That was the top. You typed at the top.
What is the top of a fraction called? So now
You're right.
Oh.
Okay, all right. Now, the next part. Now we have the asymptotes. We have the vertical. We have to make a sketch because now we know kind of the parts. This is the tricky part. This is the part where you're gonna need a calculator, and you're gonna have to set up a table to kind of see the left side. I almost guarantee the left side's fine. The middle is the ground. We got to figure out where it's going. So what we're gonna need to do, and I know a lot of you are kind of hinting at this, to figure out this middle ground, we're gonna set a table where we pick a few x numbers to plug in, just a few, and type in your calculator to see what you get. So like for instance,
1 and 1.5.
yeah, let's plug in like 1, let's plug in 0.5, let's plug in 2.
Oh,
or
wait,
not
wait,
two, but-
do it like that.
We don't need 0.5 because look, we have 2 points on either side. So I think we should do 1.5.
1.5.
Let's do
Not-
1.7.
1 and 1.5.
1.5.
Yep, those are good right there. I don't think
So-
we need 0.5.
So, hey, we'll plug these numbers into this whole problem. Now, when you plug in a number, you have to plug it into everything like I was doing earlier with the 0, and then whatever number comes out of the thing, that's the point where you have to plot. So if I'm gonna plug in 1.5, because that's one that we're kind of recommending, to kind of see where that thing's going. Again, why we're picking those numbers, I'm getting kind of a sense for where this middle ground is going.
It's going.
So if I plug in a 1.5 into this thing, 1.5 squared plus 5 times 1.5 plus 4 all over 1.5 squared minus 4. You're gonna plug that number in, whatever number the calculator says, that's the dot we're gonna graph. So we go at 1.5 for the x, that was the number I plugged in, comma, whatever number spit out. So if it's up or if it's down, we can kind of see where to plot that dot, so I can get a sense, maybe it's going upwards, or maybe it's going down to the right. It just has to be a rough sketch, so as long as you have a couple points to go off of, you can get a sense where this thing is going. And then over on this side, same exact idea. On that side, you'll have to pick a couple X numbers and plug them in and get a sense. So I would pick numbers really close to 2, and then go a couple numbers out here to see where it's going. We kind of know it's going to hug up against 1, but I need to know if it's up here or if it's down. We just need to get a sense where that thing's going. So maybe some of the numbers on this side of the graph, because again you have to do it
It's
again.
gonna be
I would
up
plug in
going
like
like this.
2.5, I'd plug in 4, plug in 7, plug in 12, get a sense where that thing is going.
Mr. Ward, it's gonna be like this.
Okay.
Okay.
Now, just to save you time, just so you can see kind of what this thing looks like, just so if you're actually plugging numbers and you want to check, like, where am I even correct?
We should have probably done negative 1.5. See if
Here we
it curves
go.
back down or curves up.
That's fine.
Oh my
That's fine.
goodness.
You can do
whatever.
that. Alright, so I'm going to type this in. Alright, what do we have? We have x squared.
You plug in more numbers.
X squared, we have a plus 5x. Plus 4, we're going to divide that by x squared minus 4. And when we graph, here's what we have. Yeah, we were pretty close to the right answer here. Okay, here's what we have. This is the actual graph that it shows on on my graphic computer. This was correct. This was correct. We had that drawn correctly. It was going to do that. And on the other side,
It's just like you have it.
Ouch. Come on.
Hustle.
I don't make that.
Do you ever get like thrilled when you see that you got the right answer? Like, does that make
Yeah, it makes me happy.
Yeah.
Alright, my calculator is pretty much dead on the spot.
Like,
Permanently dead or like temporarily dead?
It's temporarily just kind of doing a hiccup. It doesn't want to graph. So it's just spinning its wheels. I'll probably get it in about 15
I
minutes.
think that makes me the right
I'm
answer.
expecting that's the right one.
Mr. Ward, have you ever had the hiccups
Well,
before?
it's not
Yes.
asymptotes, just your reading selfish.
It is still spinning. Alright, moving on.
Wait.
We're good.
So symmetry.
Alright, symmetry. No,
Odd symmetry.
this thing is, it appears to be odd symmetry. That's what it's appearing to be.
That's the only
It's
reason
actually
that I
neither,
do.
but it appears to be odd.
Can we write odd then?
You can, if you write odd, it appears to be odd, I'm fine with that.
Wait, why does it neither?
Because it wasn't over the origin, it was shifted up.
Oh, so if we rename the origin 1 0,
Then it would be
0 1,
Yep.
Yeah.
Okay, alright, moving on.
Can
My
we
calculator will
write that?
eventually catch up to what we're doing. Okay, number 2. These are supposed to be short answers. I'm gonna do about half of these right now.
Oh!
Okay, so just so you can get a sense for this, if you get the idea and you want to blurt it out, just raise your hand and I want to know the answer for it. Okay, real quick, we're going to use this graph and these problems to estimate where the answer's going, where it's going towards. That's a limit, right? So we're approaching 1 from the left side. That's what this null negative. So as we approach left, 1 from the left, boom, you're getting 1. That's your answer. Okay? On the next part, we're approaching 1 from the right. So as we approach 1 from this side, where's my graph going?
Does not exist.
It's going to negative infinity, but if you put negative infinity, fine, it doesn't exist. It's going to negative infinity. Either one, I'm fine with that, because it's going down forever. We don't have a number it's going towards. It's going towards negative infinity. I'll accept both.
You'll accept both what and what?
This and this.
Any?
Any and that. Okay, all right, next one. Now we're approaching 1 from both sides, because they don't have a plus or minus sign on it. So we're approaching from the left and the right at the same time. It doesn't exist. They're not going towards the same number. So,
What? It's on 1. No, they're not.
No,
it's a line on the left and the right.
It would. Oh, okay.
yeah, so yeah, if the line was flowing, it would approach 1. But since the graphs are going different directions from the right and left side, that doesn't exist. So, even though, yeah, the function value is 1, but the actual limit doesn't exist because they're approaching different numbers. Okay, do we understand how that works so far?
Yes.
Okay, you guys can do the rest. They're pretty straightforward. It'll be like this. I'm giving you a graph you've definitely seen in the past. It'll be asking you a series of limits, really quick calculations. All right, moving on.
Oh, wait. Mr. Ward,
The one with the hole, at what point is it do not exist and what point is it 1?
The limit would be 1, the actual function value wouldn't exist.
So those three are.
So they
all-
wanted, if they wanted this, if they wanted f, like maybe in one of these spots, like where G says f of 2.
That's when it doesn't exist.
If they wanted just f of 2, you just plug in, not even do a limit, but just do f of 2, that doesn't exist.
That, you won't do
Thank you,
that
Mr.
though.
Ward.
So the other ones are all just gonna have the same.
Yeah, they just have to say this one.
Yeah.
Okay, I probably would.
You will or will not?
Mr. Ward, you know what would really throw us off? If you made the answer to every single problem on the whole test the same.
Oh.
I bet nobody would catch it.
No. I wouldn't do that.
You would be
Say.
so embarrassed though, because people would not get that.
Alright, next.
I got 7
Where
for
is
the
this
last
thing
13
approaching as
problems.
x goes towards infinity? So what this is basically doing, this problem is very similar to that first problem we did, the very first one we were drawing. But you're only looking towards the positive infinity side. So, when you look towards the positive infinity side on whatever this graph is doing, you don't have to graph whatever it's doing. When you look at this thing, what was the rule that I said when the bottom power is bigger than the top power?
Asymptotes at
It's at 0.
Is at 0. That's what you're going towards. The limit, as this thing approaches infinity, you're going to get 0.
So we just write approaches 0?
Approaches 0.
Oh, well,
Okay.
we can't just write 0.
So you write 0, I'm totally fine with that. But as x approaches positive infinity, this function is approaching 0. The reason being is that the bottom number is getting out to be too big, and the horizontal asymptote's at 0, so it's going to approach the horizontal line. Now, if they're the same power, it's the same problem. You take the top power divided by the bottom power. So, if this is x squared, that'd be half.
So
It'd be
then it
approaching
approaches
half.
half?
It'd be approaching
And then
half.
at the top
There's
one,
an infinity and the negative infinity.
So it approaches infinity.
And the
So,
top
if the top is bigger than the bottom, it'd go towards infinity or negative infinity, so that limit wouldn't exist.
But if they're the
So you're right,
You write Danny, or just write like it's heading towards positive infinity. Because what I would do, just plug in a big number, see where it's going towards.
100,000.
Yeah, plug in 100,000, see where the thing's going towards.
62.
Oh, it's going towards, it's going up to 500 million. That's going towards
You're
infinity.
just trying to find the horizontal.
Yeah, just the horizontal basically. And if there's no horizontal, because you did that little check, which direction are you going? Up or down? That type of thing.
How do you feel about the census?
Because that's the practical application for a limit. Like, where is that thing going if you didn't know the answer? Like, if you're going to the right forever, what would happen? Now, hey, the one thing you gotta be careful of, you gotta look at which direction I'm going. I'm going towards infinity, positive. If it said negative infinity, I'll actually type in negative infinity. So be careful of that.
Yeah, I bet he had negative infinity on the
Wait.
His calculator's still spinning, so he can't do it.
Okay,
How do you do it?
you just do the same thing you did the last one. See where it's approaching. Like, is it a horizontal line? Is it approaching 0? Is it approaching? And if it, goes up or down forever, just figure out by plugging in a really big negative number to see where it goes.
Or just remember the one thing that you
Yeah, remember the little rules. Okay, 4 and 5. Because again, we only have a couple. I want to get through number 6 today. All right, number 4. I'm gonna do one of these. It really doesn't matter which one I do.
Let's do 5.
Let's do 5. Fine. We're gonna approach this thing as we go. So here's the idea. So real quick, we're gonna simplify this thing out. I just picked a couple random ones from your problem. If they had, maybe they had something like a square here, hint, if I put a square there, we would have to simplify that thing. And then at the very end, then we plug in 0. The big thing I'm checking for, are you leaving the limit written on all of your problems as you work through it? That's
Wait,
something
are you
I've
serious?
been a very big stickler on. You have to have it there. So, I know that's not your problem, but if you had that, this is how I'd write it. I write that there's 2 of these.
But there's not.
There's not, you don't have to do this. I'll go through yours. But this is how I would write it. The next step, I would write, another limit as each approaches 0. And then I would start to FOIL that whole thing out. You guys get the idea, right?
Yeah.
All right, let's do your problem so you can see the answer. Question.
You said these won't be decimals, right?
No, they shouldn't be. They shouldn't be. Okay, so going through this,
Not our fault.
okay. So going through, we'll kind of add and subtract all these things together. Actually, this isn't your problem. So here's what we have, and if again maybe the limit doesn't exist, that's fine. You can kind of figure out where it's going. This says find one decimal place if necessary. It may not. But what I would do is like, if you can't evaluate, let's say like you can't plug in h of 0, because we'll see that in this problem. You might have to set up a table to see kind of what's happening as you get close to 0.
Why aren't there?
Okay, so here's how it works. So I'm going to distribute the 3 through this problem, right? So I get 3 times 2, and I get the 3 times h, and no, you don't have to write this. I'm just showing you what I'm doing. So, multiplying the 3 through, so this is what I get limit as h approaches 0 of 6 plus 3h
There's not gonna be.
minus 12 all over h, okay? And then you can add and subtract like numbers, so I get 3h minus 12,
You're gonna go straight.
Minus
sorry,
6.
6, what am I doing?
All over
All over h, and there's the limit as h approaches 0. Okay,
Zero for H?
so,
We'll just leave you with an H.
okay, do we see what we have so far?
Yeah.
Divide H.
We have to divide both sides by h. Okay, so here's what we have. Okay, so I'm at the point where I'm at this.
3 minus 6.
I'm at the point where I divided both by h, and I have 3 minus 6 over h, right?
Wait.
Because you have to divide both numbers by h. Okay, I know that seems weird. I divided the
Wait, you
3.
can't just cancel the h out of the
You
bottom?
can't just cancel them out?
No,
No.
because the 6 didn't have an h on it. You have to divide both by h.
Yeah, and then you plug in 0, and then it's just 3.
Okay, so if you were to plug in 0, because I want to plug in 0, I can't do that. Because you can't divide by 0,
Yes, you can.
right? You can't do it on this one problem I gave you. On most problems, usually you'll only have like h's left, so you can divide everything by h, plug in zeros, and see what happens. But in this case, I can't plug in a 0. And you still got to figure out, what is this thing going to do when I try to evaluate it? So what you need to do on a calculator is plug in numbers. I would try like 0.1, because that's a number close to 0. Try the number 0.001.
What are you trying to get?
I'm trying to get as close to 0 as possible without actually hitting
So
0.
this was like the homework that like we didn't know what to do, but then we found out because you're not supposed to plug in 0, you're
Yeah.
supposed to plug in something else, but we didn't know that.
So you got to plug in 0001
Right, exactly.
to see where that thing's going, or
Negative 5,900.
Wait, why aren't you're not writing limit
That's
as h
600.
approaches 0?
I'm evaluating. I'm evaluating.
That's
Okay.
600.
For a point, zero, the other one. That is negative 5,900.
Yeah, that's what about the 600.
Okay.
Wow.
Negative. So,
Oh, yeah, negative.
okay. Now the other thing I'm going to check. I'm going to plug in negative numbers. What happens if I plug in negative 0.01? Because that's really close to 0, or negative 0.00001. I want to figure out where all these are going. The reason why I'm going on the left,
The opposite of the other one.
It's gonna be
As I go
positive
to
6,000.
left and right of 0. I need to know where this thing's going. It looks like on the right side, as I'm getting close to 0, these numbers are turning out to be negative, like really small negatives, like negative 6,000.
That's a small
That's
negative.
way down here. Negative numbers are really small.
That's
So-
a big negative.
So what type of answer
are you looking for?
I'm looking for in this problem is
Negative.
what is that thing roughly approaching? Is it going towards negative infinity? Is it going towards positive infinity? Is it approaching a number, a single digit? Because
Shouldn't it be 3?
on certain problems, you might actually have this thing approach a number. Because maybe this is a problem. Maybe you had something like this.
What? This gives me actual like hour time.
This gives me actual hour right now.
That's how it works.
So, maybe this is your problem. And, because I said you might have powers in this. Well, when you evaluate this thing, you're eventually going to get down to like 27 plus h cubed plus blah, 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 blah. And then eventually you have all these items over here. So that's, this is the top. And then remember, maybe the 27s cancel out. So you have a bunch of things with h's in it. And it's all divided by h. So then the idea is that what you're going to have is you're going to divide everything by h's, so this is what you'll be left with.
Right, so you're finding the derivative, right?
Yeah, it's kind of like you're doing a derivative,
Yeah.
but the problem is, they want you to figure out what happens when you get close to 0. Well, this one, maybe you're going towards infinity on both
No,
sides.
you're
of
going
it.
towards
It's
positive.
going to positive?
Yeah.
Fine.
That
So,
was fine.
what happens as your limit approaches 0?
3 plus whatever number, because
Yeah,
it's
so-
2 negatives cancel.
So, what's happening here is that on this particular problem, this thing doesn't
Does
exist.
it determine what numbers you plug in?
It doesn't exist because it's going to 2 different numbers when you go towards 0. As you
Does it
get
depend on
closer,
what numbers you plug in?
it depends on the numbers. So
You can
if,
get any answer.
yeah. So, hey, on this problem, on this problem, as, let's say this is your problem, you're simplifying it down, and you get to this point where now you're about to evaluate, when h approaches 0. Well, when I plug in a bunch of zeros here, eventually, my answer is 6. So that one actually has an answer.
Okay.
What are you even talking about? Is it even the same
I
problem?
thought you said we can't.
Oh my
plug in
god,
zero.
no, I can't. This is
Only if it's being divided by 0. Because then you have to divide by 0 error.
Yeah, so anytime you have to plug in these really small numbers, when you have these like divided by 0 things where they didn't go away, and.
Is that how you're gonna make this on the test?
Okay.
Yeah.
Maybe the examples I'm coming up with are probably really good ones.
some easy ones.
Yeah, but you
Just
said that
saying.
it's gonna be scored
Are
later
these
on the
examples?
test.
Is this on the test?
Problems like this, yes.
I don't
No,
understand
exactly that.
what one is.
But you said that the one on the test is gonna be squared.
4 and 5 both did not exist.
Maybe.
What is going
I'm
on?
moving on, I don't like the whining. I'm moving on. So,
Yes.
I literally don't understand. This isn't even sense.
so, moving on. Number 6.
What do you
Word document.
Why is that thing?
I honestly
Why do you have like a box like that? What does that mean?
It's a text box.
Why is it no? Why is it?
Yeah, he has answered text box.
Okay, alright, moving on. Okay, on this problem, we have to find the first derivative, and that's the instantaneous rate of change, and then you have to evaluate it at 2. So it's just like the last ones you did, but these are gonna be pretty straightforward. This is the formula you're gonna have to use, and yes, this will be on the board, it'll be on that board, you guys will be facing that way on Thursday. And here's your formula, so as h approaches 0, it's f of x plus h minus f of x. It's basically the same thing we were just doing in the last problem. Over h. So, you're using this formula, you're evaluating at that formula that they have over there. The setup is the hard part. If you can get the setup done correctly, then you can immediately evaluate the differential quotient, where h is 0. This is the thing that I was showing you a little bit ago, where it can simplify down. And then at your last step is you have to plug in 2's for the cube. So you're evaluating. So the whole point is doing that. So this is the first derivative, whatever this thing turns out to be. But what we need to do is figure out what happens when you plug in a 2 eventually. You have to save the 2 for last, because I do want to see everything. So to do this problem, we have to take your original function, which is the 100q, and we're doing the x plus h, which is q plus h in your case, because we're using q's.
If we put in an X, are you gonna
You're
be
fine if you plug it in.
Awesome.
Minus, what is that? 10q plus h's squared. Alright, so that's this part. That's plugging the x plus h or q plus h, I guess, in your case. In, if you want to plug x's, it's fine. I'm totally fine with you doing that. It's like this. So if you're that person, do that. So that's this part. That's the x plus h is plugged into your original problem over there. Then we're going to subtract the original function off. So you're going to be subtracting 100x minus 10q squared, or 10x squared, sorry. We're sticking with x's.
That's okay.
That's your original thing, and then we have to divide everything by h, and there's a limit as h approaches 0. So you have to simplify this thing down. FOIL it, distribute it, whatever you need to do, simplify. Things that don't have h's should go away. And then you'll be able to divide everything by h eventually. And then, so I'm gonna go through this so you can see this problem. So going through this problem, I'm gonna do all this math really quickly. Limit as h approaches 0. We're gonna have 100x, 100h, minus 10x squares, minus 20xh's, minus 10h squares, minus 100x's, minus 10x squares.
We have to leave
One
Lynn.
X8.
It'd be a plus 10x squared.
Plus 10x squared, thank you. Just make your signing correctly.
Okay, will you tell me if I did it right?
And we have an h all on the bottom. Now, what should happen here, what did I tell you if you set up these problems correctly?
They're gonna X cancel.
Anything that doesn't have an h should cancel.
Yes.
You just square that x plus h and that one, and just
Yeah.
Sure.
Yeah, this part is the part I'm really worried about. This part right
It's not
here.
mine right now.
That.
Why?
Because what I can definitely foresee happening is people will look at this and go, oh, that's x squared plus h squared. They'll just distribute the 2. When you're actually supposed to write 2 parentheses and FOIL, and that's what you're seeing here. I've actually FOILed it in my head and distributed the negative 10 at the same time.
I wish I could do that. But you can.
Mr. Ward, is the answer 60?
Can I do you a favor and blow your mind?
Mr. Ward, is the answer
Listen to this. Mr. Ward, Reese is about to blow your mind. It's actually a revolutionary economic theory.
Reese, what is the theory? Reese, what is the theory?
Mr. Ward, listen to this. Okay, so, since negative 5,000 is a small negative,
Sunny, do
right?
you want to sign this out?
If you are in debt $1, you are actually in debt more than somebody who's in debt negative 5,000 because 1 is a bigger number.
You're in a lot of debt compared to percent-wise.
So you should tell people if you have $100,000 in debt, you're actually doing quite well because that's a low amount of debt because that's a small number.
No, I'm talking about negative debt. That's when the bank owes you money.
No, we're just talking about debt in general.
So if you're 5,000
By the
in
way, my
debt,
calculator never actually calculated.
yeah, that's actually better than being $1 in debt because
I
it's
have
less
a
debt.
car loan, I'm negative $2,000 in debt. I'm actually richer than somebody who's
What's the deal? How did I miss this?
You don't like that?
What?
I hope so.
It's the same thing.
I'm insane. It's this right now.
I shouldn't.
It's sad.
Reddit just asked if I made her cry.
I was just asking.
It's just the ones who calls you fat,
Hey,
entitled, and a job.
thank you
Yeah,
for letting me do my
she almost made me cry, goddamn.
Okay, well, I'm not gonna say that.
Carly B, bro. She
I
called me
said fat.
Yeah, nothing came out of my mouth.
He told me to say it.
Yeah, but I didn't say anything.
Brett, why didn't
He
you-
was teeing off on
Why
that.
didn't you go in front of the class?
Because I didn't want to.
Oh, I didn't want to either.
I wanted to.
I would have said some things about you.
I would have said. I would have said.
What?
Growing up.
Get it?
You ready, Kenny? Look at me for a second.
10 minutes, Patty.
Scumbag, you already.
Hey!
No, don't do it.
I can't.
Unless you got a password.
That's hilarious.
Alright.
Don't say scumbag.
I forgot my phone.
I was talking to you.
Well, I don't care. It's still gonna make me.
Okay, I was not hurt your feelings.
Yes. Mr. Ward.
Genius.
I had senior study hall, so I don't.
So that means you should have been the first in the room?
No, that means no one's there to give me a pass.
Oh. So you told me.
That just hurt your
So
case
hey, you're
worse.
actually
No.
confessing that you're like, got it. Okay, good.
How did that hurt her case worse?
What?
Maddie.
She was at
So,
least
first
getting
one, like you're
a
saying,
pass.
you should get the guys.
What? The thing is, she was late. How are you late from City Hall?
You were late.
No, I was talking to Briley and I got a pass.
Anyone that did not receive a practice test yesterday?
Okay, on this test.
Okay, anyone else not receive one?
Ow.
Okay.
Okay, yesterday's video.
That was
I'll
sharp.
make make sure it's on the website tonight. I'm gonna post today's video as soon as I can right after school. That way you can go back and watch those videos. You can see how we did the first half versus second half and all that good stuff. Yep.